Hello and welcome again to my second video in my series on waves. In this video I'll be covering key concepts of wavelength and period. By the end of this video you should be able to count the number of waves in a wave train. You should be able to state the definition of a wavelength. You should be able to state the symbol and units of wavelength. Be able to calculate the wavelength from basic examples. State the definition, symbols and units of a wave period. And finally be able to calculate the period if you know the frequency. So in the first half of this video I'll be discussing the wavelength. Take this group of waves. This is called a wave train. How many waves do you think are represented here? To count waves we need to start from the left hand side. Just like reading a book. One wave is a cycle that goes up and down and then back to the start, like this. If we repeat this process, we see that we have 1, 2, 3, 4 waves. Knowing how to count waves allows us to calculate wavelengths. So what is a wavelength? A wavelength is the distance from one part of a wave to the same part on the next wave. A simpler definition is just simply the length of a wave. The wavelength is measured in meters, and the wavelength has lambda as the symbol. Lambda is a letter from the Greek alphabet. You'll find that a lot of quantities in physics are represented by Greek letters. So let's take this wave train of 4 waves. Normally a wavelength is measured from crest to crest. However, we can measure it from trough to trough. You'll see it's exactly the same distance. In fact, we can measure a wavelength from any part of a wave to the same part of the next wave. So here's a problem for you. If the distance from the start of this wave train to the end of it is 20 meters, what is the wavelength? Feel free to stop the video and have a little think about it. Well, if we've got 4 waves there and they take up a total distance of 20 meters, then one wave is the 20 divided by 4 because there's 4 waves. Which means that one wave has a wavelength, or lambda, of 5 meters. Here's another example for you. This one's a little trickier. Again, I'll give you a couple of seconds to have a think, or feel free to pause the video. So we need to know how many waves take up the 15 meter distance. Using our ability to count waves, we see that there's 1, 2, and a half waves that take up 15 meters. This means that the wavelength is 15 meters divided by 2.5, or 6 meters per wave. For the last part of this video, we'll be discussing the period of a wave. The period of the wave is the time taken for one wave to pass a point. It's represented by the symbol capital T. Because it's a time, it's measured in seconds. Have a look at the wave train here. Let's say the waves had a frequency of 2 Hz. That would mean that 2 waves are passing the arrow per second. If you have a think about that, it would imply that a new wave passes the arrow every half a second. This is the period, 0.5 seconds. If the frequency was 10 Hz, it would mean that we were having 10 waves per second passing the arrow, and a new wave every 10th of a second, giving us a period of 0.1 seconds. You can see that the period is 1 divided by the frequency. In fact, the period and the frequency are the inverse of each other. Meaning that if we know the frequency, the period is 1 divided by the frequency, And likewise, if we know the period, the frequency is 1 divided by that period. Here we have a question from the 2017 National 5 exam paper. I'll give you a little minute to think about it if you want to have a go. Feel free to pause the video, but in order to calculate the wavelength, the frequency and the amplitude, you may need to watch the previous video that I put up. I'll put a link in the description. To calculate the amplitude, we see that the height of the wave from crest to trough is 2.6 meters. The amplitude is measured from the centre line or the axis. This would mean that it's half of that distance, or 1.3 meters. To calculate the wavelength, we see that the full wave train from X to Y is represented as a distance of 12 meters. Counting the waves, we see that there's 4 waves there. So the wavelength would be the 12 meters divided by the 4 waves, given a distance of 3 meters per wave. For the frequency, we need to know the number of waves per second. If we have 4 waves, and it tells you that these were created in a time of 0.5 seconds, then 4 divided by 0.5 will give you a frequency of 8 Hertz. Also from the same paper, we have this question. The student's observing water waves entering a harbour and measures the time for one wave to pass a point to be 2.5 seconds. This is the period of each wave. To calculate the frequency of the waves, it's 1 divided by that period. This gives us 1 over 2.5 for a frequency of 0.4 Hertz. So in this video, we've covered a few things, but by now you should be able to count the number of waves in a wave train. You should know that the wavelength is the length of one wave, or the distance from one part of a wave to the same part on the next wave. The symbol for wavelength is lambda, and is measured in meters. We've been through examples on how to calculate wavelength. The wave period is the time taken for one wave, represented by the symbol capital T and measured in seconds. And finally, we've gone through an example on how to calculate the period from a given frequency. Thanks for watching. Until next time, feel free to like and subscribe. Bye.